And we're looking at eigenvalues and eigenvectors. We'll be solving one of the problem to find the eigenvalues and eigenvectors. Please like, share and subscribe this particular channel. Let us start now. Now coming to eigenvalues and eigenvectors. Okay, first we're looking at definitions of it. First we're going to eigenvalues. Let A be a square matrix of an order n. Then the roots, that is nothing but lambda, values of the characteristic equation mod of a minus lambda I is equal to 0 is called eigenvalues or characteristic roots or latent roots of an A. Okay, A is in a square matrix. Okay, and I is nothing but identity matrix. Then lambda or the roots that we get it for the square matrix A is called as an eigenvalues. Okay, now coming to eigenvectors. A non-zero vector x such that a minus lambda I x is equal to 0 or ax is equal to lambda x is called eigenvectors or characteristic vectors or latent vectors of characteristics to the eigenvalue of an lambda of an a. Okay, for this particular root or eigenvalue lambda, there would be one eigenvector also, that is known as an x. Okay, such that a minus lambda I into x is equal to 0, or you can say ax is equal to lambda x. Okay, the one more thing you have to know is nothing but mod of a minus lambda I is nothing but characteristic polynomial. Okay, which is only one of the problem for better understanding. Now coming to the question. Find the eigenvalues and eigenvectors of a matrix A. Right. So first we're defining the eigenvalues, then we're defining the eigenvectors. Okay. So we're going with an eigenvalues first. From that one, you are defining the eigenvectors, right? So eigenvalues are nothing but you have to find the determinant of a minus lambda I should be equal to 0, right? What is a matrix? It is given here. It is a 3 cross 3 matrix. So I matrix, identity matrix I is equal to nothing but it becomes 1 0 0 0 1 0 and 0 0 1, right? This is an identity matrix. Then we get in a lambda times of an I, which is equal to nothing but it becomes lambda 0 0 0 lambda 0 and 0 0 lambda, right? So we have to find the determinant of it, should be equal to 0. So first we're substituting it a minus lambda I, you get as nothing but just subtract this matrix with this matrix, then we get 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda, right? We got this particular matrix. Now we have to see that determinant of an a minus lambda I should be equal to 0. So find the determinant of this one. So it becomes 8 minus lambda into 7 minus lambda into 3 minus lambda minus 16, right? Then it becomes plus 6, right? All the minus sign is there here. So into it becomes minus 6 into 3 minus lambda, minus minus get cancelled, so it becomes plus 8 plus 2 into 24, this minus 2 into 7 minus lambda, right? So just substitute this particular values. We get this one as 8 minus lambda into, just multiply these two, okay, and minus with a minus 16. So it becomes 21 minus 10 lambda plus lambda square minus 16, right? So it becomes lambda square minus 10 lambda, and this is nothing but plus 5, right? Again subtract these particular values here. It becomes minus 18 plus 6 lambda plus 8, right? So it becomes plus 6 into, here it is nothing but 6 lambda minus 10, right? I'm going to substitute these particular values here. So it is nothing but 24 minus 14 plus 2 lambda. So it becomes plus 2 into 2 lambda plus 10, right? So again we have to multiply this value with this one. So individually we'll be doing it. So it becomes 8 into lambda square minus 80 lambda plus 40. Again it becomes minus lambda cube, and this is plus 10, right? So it becomes minus 10, so it becomes 10 lambda square minus 5 lambda. I can multiply this two, it becomes 36, right? So plus 36 lambda minus 60. Again multiply these two, it becomes 4 lambda plus 20, right? So just after this particular values, it becomes minus lambda cube, it becomes plus 18 lambda square, and this not becomes 40, right? This is 40, this is 85. So 85 minus 40, it becomes 45, right? So it becomes minus 45 lambda, and these values, right? 60 and 20 minus 60, so it gets cancelled, is equal to nothing but 0. This particular equation we got it. So it is nothing but, if you take lambda common, okay, then it becomes lambda square minus 18 lambda plus 45 is equal to nothing but 0, right? Remove the minus also, so we can write this one as lambda into lambda minus 15 into lambda minus 3 is equal to 0. So lambda values is equal to nothing but 0, 3, 15. These are nothing but eigen values. Okay. Now we have find the eigenvalues. Now we'll find the eigenvectors. Okay. It's nothing but eigenvalues. We know that lambda is equal to 0, 3, and 15. Now we're going with an eigenvectors. Right. So eigenvectors are nothing but when you multiply a minus lambda I with an x is equal to 0, where x is nothing but a column matrix given as x, y, and z, right? So we have to substitute it and find the value of x, y, and z with respect to the eigenvalues. So here a minus lambda I, we already know it, right? We just substituted it. A minus lambda I is nothing but this particular value. So it becomes nothing but 8 minus lambda minus 6, 2 minus 6, 7 minus lambda, and this is nothing but minus 4. This is 2 minus 4. This is 3 minus lambda. Just I have written down the a minus lambda I. Okay, this is a minus lambda I, right? Now we multiply with an x, so it becomes x, y, and z, right? Is equal to nothing but 0. What is the lambda we have to take is nothing but, first we'll take with an 0. Now come to the case 1, where lambda is equal to nothing but 0. So just substitute the values here. We get this one as 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3. And this is nothing but we get as x, y and z is equal to 0. If you want to write in the form of an equation, 8x minus 6y plus 2z is equal to 0. And this is minus 6x plus 7y minus 4z is equal to 0. And this is 2x minus 4y plus 3z is equal to 0. Now we have to solve this particular three equations to get the value of x, y and z. For this one we are using cross multiplication method. Okay, using cross multiplication method. What we do is nothing but take the middle term, last term, first term and middle term in the form of a row. Okay, what we do is nothing but take the middle term, say 7. It becomes 7. Last term minus 4, first term is minus 6 and middle term is 7. Go to the second equation. So it becomes, this one is minus 4, this is 3, this is 2, this is minus 4. Right? Now we'll be cross multiplying these two. Okay, as in a cross multiplication method. So it becomes x divided by 21 minus 16, which is equal to y divided by minus 8 plus 18, which is equal to z divided by 24 minus 14, which is equal to 1. Then we get this x by 5 is equal to y by 10 is equal to z by 10 is equal to 1. So we can substitute this particular values, right? 1 it goes by 2 it goes by 2. So we got the eigenvectors, right? There's nothing but x, y and z. These are the eigenvectors, which is equal to nothing but we got this particular values as 1, 2 and 2. These are values when lambda is equal to nothing but 0, right? Now we go into the case 2. It's nothing but when lambda is equal to nothing but 3. Just substitute the values. Okay, when you practice more, you get the more. Okay, then we get here lambda is nothing but 3. So 8 minus 3. So we get as nothing but 8 minus 3. So it becomes 5. This is minus 6. This is 2. And this is minus 6. This is 4. This is minus 4. This is 2. This is minus 4. And this is nothing but 0. Right? So again we'll be writing in terms of a middle, last, first and middle term. Consider any of the term. Okay, if you consider this term and this term, so it becomes minus 6, 2, 5, minus 6, and this becomes nothing but minus 4, 0, 2, minus 4. Right? So again we define the value of an x, y and z. Now we'll be getting the value of an x, y and z. Right? Just by cross multiplying it. Right? So it becomes x by 8 is equal to y by 4 is equal to z by, it becomes minus 20 plus 2 is equal to 1. Then you get x by 8 is equal to y by 4 is equal to z by minus 8 is equal to 1. So 2 it goes by 1 it goes by minus 2. So again we got the eigenvectors. It is given as x, y and z is equal to nothing but with this particular value as 2, 1, minus 2. Right? These are the values when lambda is equal to 3. Now defining it for case 3. When lambda is equal to 15. So again we're getting a matrix. Right? It's nothing but 8 minus 15. So we get as nothing but minus 7 and just minus 6, 2, this is minus 6 and 7 minus 15. So it becomes minus 8. Again it is minus 4. This is 2. This minus 4. And 3 minus lambda. 3 minus 15. So it becomes minus 12. Right. Now again we'll be doing a cross multiplication. Consider this particular two terms. This one and this one. Okay. So we get as this one as minus 6, 2, minus 7, minus 6. Again here we get minus 8, minus 4, minus 6 and minus 6. Right. Again we're finding the value of x divided by, it becomes 6 4 is 24 plus 8 2 is 60 is equal to y divided by, it becomes 6 2 is comes minus 12 minus minus 7 4 is 28 is equal to z divided by, it becomes 8 7 is 56 and this one becomes minus 36. Right. So it becomes x divided by 40 is equal to y divided by minus 40 is equal to z divided by 20. It goes one and 2 is it goes by minus 2 is it is an 1. So again we got an x y z value, x y and z. Yes or no? Which is equal to nothing but we got this one as 2 minus 2 1. This is the case when lambda is equal to 15. So these are the methods to find the eigenvalues and eigenvectors. Come to the next question. The question is the product of non-zero eigenvalues of a matrix. The matrix is given, it is an A 5 cross 5 matrix. So we'll be having 5 different eigenvalues. That's not the lambda. Now how to find the eigenvalue is nothing but we have to find the determinant of A minus lambda is equal to 0, right? So just substitute this here. You got a straight line here and a straight line here. So it has 1 minus lambda 0 0 0 and this is 1 and this is 0 0 0 1 and this is 1 minus lambda 1 1 and 0. This is 1 1 minus lambda 1 and 0 and this is 1 1 1 minus lambda and this is 0 and this is 0 0 0 and 1 minus lambda. This is a matrix, we got it, right? We have to find the determinant of this one, right? For this one what we do is nothing but use a general formula, minus 1 power I plus j into EF ij, okay, into determinant of a matrix. Okay, I and j are nothing but row and columns. So we get this particular terms. Okay, consider the first term 1 minus lambda. So it becomes nothing but minus 1 power, it's an A11, right? First row, first column, 1 plus 1 into 1 minus lambda. Then draw in a straight lines here, here. Do not consider row and column of this particular A1. Okay, first row and first column. So consider only the other terms. So we get as 1 minus lambda 1 1 and 0. This is 1 1 and this is 0. The other terms are 1 minus lambda, this is 1 and this is 1, this is 1 minus lambda and this is 0 and this is 0 0 1 minus lambda, right? So again consider the other term 1, it is an A1 and it's in a fifth column A5, right? A1 5, so it becomes plus minus 1 power 1 plus 5 into 1 and draw in a straight line here and here. So consider the other terms. We want to consider row and column of this particular first row and fifth column. consider only the other terms. Okay, from here to here. So it 0 0 1 0 0 0 and 1. The next one is 1 minus lambda 1 1 0 1 minus lambda 1 1 0. Another one is 1 this one, right? 1 1 minus lambda 1 and 0. Another one is 1 1 1 1 1 minus lambda and 0, right? Again we got an 4 cross 4 matrix, right? So now 4 cross 4 matrix. Again we have to use the same formula. Okay, so this one becomes nothing but, on substituting this one, it becomes 1 minus lambda into this 1, right? Into 1 into, now here remove the row and column which has an zeros. Okay, and we're removing this one and this one, and so only this particular term. So it is A44, right? So minus 1 power 4 plus 4 into 1 minus lambda, and consider the other terms. So draw a straight line here, here. So it becomes 1 minus lambda 1 1 and 1 1 minus lambda 1 and 1 1 1 minus lambda, right? Plus here we'll be considering this particular one. Okay, remove the row and a column. This is an a 1, so it is an a it's an a fourth row and first column, right? 4 1, so it becomes minus 1 power 1 plus 4 into this is 1 into 1, right? So it becomes nothing but 1 into 1. Again draw in a straight line. So it becomes 1 minus lambda 1 1, and this is 1 1 minus lambda and 1, and this is 1 1 1 minus lambda, right? So from here we got that, I'm writing top. So we got 1 minus lambda whole square into this particular matrix. Okay, if you consider this particular matrix, say it is a B matrix, both of them are same, right? Into, you have to find the determinant of an B minus 1 into, you have to find the determinant of an B. So which is equal to nothing but, we can write this one as 1 minus lambda whole square minus 1 into, you have to find the determinant of a matrix B, right? So first we'll find the determinant of this particular matrix. So it becomes 1 minus lambda into 1 minus lambda whole square minus 1, and next term is minus 1, and this is 1 minus lambda minus 1 plus 1 into, it becomes 1 minus 1 plus lambda, right? So these two get cancelled, these two get cancelled, minus 1 get cancelled, becomes 2 lambda, right? So we have to find this particular value now. Now this one is nothing but, it becomes 1 minus lambda into lambda square minus 2 lambda plus 1 minus 1 plus 2 lambda, right? Which is equal to nothing but, we get as this two get cancelled, right? So just multiply these two, it becomes lambda square minus 2 lambda, then it becomes minus lambda cube minus 1 gets cancelled, it becomes plus 2 lambda square, right? 2 lambda square, and it becomes plus 2 lambda, right? So on substituting it, these two get cancelled, right? It becomes nothing but minus of lambda cube plus 3 lambda square, right? So this one we got it B value. So it becomes nothing but, on squaring this particular value, it becomes 1 plus lambda square minus 2 lambda minus 1 into this particular term, it is nothing but lambda cube minus lambda cube plus 3 lambda square, right? So minus plus it get cancelled here. So we can write this one as nothing but lambda into lambda minus 2 into lambda square into minus lambda plus 3. Right? You have to equate this one to 0. Right? You have to get non-zero eigenvalues. You can see that there are 5 eigenvalues. 1, 2, 3, 4 and 5. Non-zero eigenvalues are nothing but this value and this particular. So lambda is equal to nothing but we got as 0, 0, 0, 2, 3. So non-zero values are nothing but 2 and 3. So product of non-zero eigenvalues means lambda is equal to 2 and 3. So product of them is equal to 2 into 3. It is equal to 6. Right? So answer is option in the question 6 is the answer.